Hi everyone, this is Brian from Kaizen Academy, and today we've got a new question requested by Scott. So this Scott has requested a 2-unit question, and more specifically a question relating to maximum and minimums. So a good choice, Scott. But this question I found from a recent HSC paper, I think 2009. But the question here I think is quite good because it's not your traditional maximum and minimum question. It does require a bit of thinking. The answer isn't as obvious. It's not just finding the maximum minimum of a curve, but rather we're solving a problem itself. So let's get started. An oil rig S is 3 kilometers offshore. A power station P is on the shore. A cable is to be laid from P to S. It costs $1,000 per kilometer to lay the cable along the shore, and $2,600 per kilometer to lay the cable underwater from the shore to S. The point R is on the point closest to the shore to S, and the distance PR is 5 kilometers. The point Q is on the shore at a distance of X kilometers from R, as shown in the diagram. So we see in the diagram here, that's exactly what they've said in the words. The only thing I think we should take from the words, which is most important, is actually the cost. So the cost of $1,000 per kilometer along the shore and $2,600 on the cable underwater. So those two numbers are probably the most important things from that first paragraph. The diagram pretty much explains the rest. So let's get into it. So the first part asks, find the total cost of laying the cable in a straight line, P to R, and the straight line from R to S. So fairly straightforward. We've got to find the cost of laying the cable from P to R and the cost of R to S. And we add those together, that's the total cost. So the cost of PR, what's the cost of laying the cable? The cost of laying the cable would just be the cost per kilometer multiplied by how many kilometers we have to lay. So PR here is on the shore, right? So our cost on the shore, as we see in the question, is actually $1,000. And in kilometers, P to R here, according to the diagram, 5 kilometers. 5 kilometers. So therefore, our total cost of this part, P to R, along the shore, is 5,000 kilometers. Cool. Now to find the distance RS, it's the exact same thing, right? RS, the difference here, but RS is not on the shore. It's actually in the water, right? This is our oil rig outside on sea. This is our shore here. So because we go underwater, our cost is actually $2,600, as you see in the question. So similar thing, $2,600 as a cost. What about the distance? The distance here, RS, is actually 3 kilometers. So let's multiply that by 3. That would be equal to approximately, what's that, 7,800? Cool, so we have our cost of laying the cable P to R, which is 5,000, and the cost of laying the cable R to S, which is 7,800. So let's add that together. Our total cost, let's just write that manually. 12,800. Cool. That's our first part done. Not too hard at all. So let's move on to part I, the next part. So next part, part I, reads, find the cost of laying the cable straight line from P to S. So P to S, let's have a look at the diagram. So P to S here is this point here, this point here. So we'll see that P to S actually is completely underwater, right? It's not, we don't have to go along the shore at all, it's completely underwater. So similar to last question, in order to find the cost of laying P to S, we need to know the cost of laying PS. We need to know the cost of laying the cable per kilometer multiplied by the distance PS. So what here is the cost per kilometer? Let's have it. So P to S is completely underwater, right? Because the shoreline is here, the oil rig is out here. If we go to P to S, this distance here will be completely underwater, right? So actually, let's draw this out. So let's draw this out. This is our right angle triangle. It's S, R, and P. So we want to find distance P to S, right? So we want to find distance. We know that the bottom P to R is 5 kilometers. P to R 5 kilometers, and we know R to S here is 3 kilometers. So how would you find distance PS? Well, we see there's a right angle triangle, and we are given all sides except for one. So naturally, we choose Pythagoras theorem. So let's find distance P to S. So d squared PS equals 5 squared plus 3 squared. So let's do this very quickly. dps would just be root 34. Cool. So now we know the distance of PS. We know the cost of laying the cable underwater, P to S. Let's find the cost of PS. CPS here would be equal to $2,600 because we're going underwater for P to S. Multiply the distance PS, which is root 34. Get this on a calculator. 15160 47 cents. You probably don't need to go cents, but just because. Cool. That's I done. Not too bad as well. Not too bad as well. So far it's fairly. The question's not too crazy. All we've just got to do pretty so far is just find the distances of what we gotta calculate. We know the cost because the cost has been given to us, so it's not too bad so far. Next part, part 3. Let C be the total cost of laying the cable in a straight line from PQ and then a straight line to QS. So what does this mean? What does it mean? We want to lay our cable P to Q and Q to S, and we're given that we have to show that the cost is what they've given in given to us here. So let's write down what they're required to show. So RTS for required to show. C equals 1,005 minus X plus 2.6 root X squared plus 9. Cool. So we've got to show that C equals this. So remember, we should do our question the exact same way as before. We're finding a cost of laying a cable, right? So what we've got to do is multiply the distance of what we're trying to lay, multiply the costs. So distance times cost per kilometer is our total cost. So we see here actually our shape of our cable here isn't actually just a straight line. So we see here is PQ is one line and QS here is to another line. So we've got to do two parts to this. So let's start with PQ first, our cost of PQ. Cost of PQ, right? So cost of PQ is the cost per kilometer. So see PQ here is completely on the shore, so our cost is $1,000. And then we've got to multiply by our distance PQ. So PQ, what's the distance from here to here? Well, we see here the total distance from P to R is 5 kilometers, and this distance here is X kilometers. So if we get 5 kilometers and we minus X away from it, we're left with this distance here. So what's that? 5 minus X? Exactly. Cool, so that's our cost PQ. That's our first part of the question done. So that's our first part of the cable. What's that next part of the cable? Next part of the cable, it says Q to S. So how do we find the Q to S here? So exact same as the previous question. Q to S. We got to find the cost of Q to S, right? So what's the cost per kilometer if we go Q to S? So we see Q to S here. This is the shore. This is in the water. So if we're going to go from Q to S, we've got to lay our cable underwater, right? And our cost of that, as you see in the question, is $2,600. And then we've got to multiply this by the distance. So what's the distance QS? So we're actually not given this, right? But very similarly, let's write down QS. Very similarly to the previous part, we said this is a right angle triangle where we're given two sides, and we need to find a third side, right? So naturally, I'll draw a triangle out here. So I'll draw this out. So R, S, Q. Take this triangle here and just bring it out to here to rewrite it. X, 3. We need to find this distance here, QS. So how do we find that? Pythagoras theorem, of course, right? So DQS squared equals 3 squared plus X squared. Let's do this very quickly. Square root it, add these things together. So 3 squared is 9, X squared is just X squared. If we want to find our cost QS now, we have our distance QS. Let's write that in. So cost QS will be equal to $2,600 multiplied by DQS, and that's exactly that. 9 plus X squared. Okay, cool. So Remember the question was, find the total cost of laying the cable from PQ to QS. So we know our cost of PQ, which is we found right here, cost of QS, which we've got right here, which we found. So let's add them together to find the total cost. The total cost, C, so it would be CPQ plus CQS. So we see that, it's 1,000, 5 minus X, plus CQS, which is this one down here, 2,600 multiplied by 9 plus X squared. Cool. So how do we get from what we have here? Sorry, this is a dollar sign. So how do we get from what we have here to all the what we have here? So we see we already have the 5 minus X, right? We've already got the X squared plus 9s. It's quite similar already. So the only difference here is if we can see, it's been factorized out, right? So we see that 1,000 on the outside multiplied by a bracket. We've just got to do the exact same thing to this. Let's factorize 1,000 out of this whole equation. So 1,000 factorized out of this whole equation would be 5 minus X, so 1,000 out of that. So 1,000 factorized out of this part, we've just got to divide the 2,600 by 1,000. So 2,600 divided by 1,000 is 2.6. And I'm just going to rearrange what's in this root here all the way around, so it's exactly the same as what the questions asked. So there we go. We've got exactly what the questions asked us to prove it, and we've got exactly that. So not too crazy. Just the tough part is, you've got to recognize that in order to find QS, we've got to use Pythagoras theorem to find the distance. But from there, it's the same as every other part, right? We just get our cost multiplied by our distance. Cost per distance multiplied by distance, and we get our total cost. Cool. So let's move on to our next part, part IV, part 4. So part 4 asks, find the minimum cost of laying the cable. Okay. So we want to find the minimum cost of laying the cable. So first of all, let's get our cost equation that we got from the previous question and just rewrite what we got here. So we've proven that the cost of laying the cable is 1,005 minus X plus 2.6 X squared plus 9. So up to this point, the question has been fairly, I guess, self-explanatory, kind of straightforward. We've just got to find the cost by multiplying the distance by the distance, cost per distance multiplied by distance. But here is where we're actually doing the maximum minimum part of the question, the part where we get the most marks. So we see it's worth 4 marks here compared to the rest of the question. So we've got to find the minimum cost of laying the cable. How do we do this? So I want you to pay attention to something very quickly. Pay attention that this cost equation has an X in it. We don't know what X is. X here represents a distance that is within this 5 kilometers. So if pretend if X was 5, right, then this triangle would come all the way out to here. But if X was 0, this triangle will come all the way into here and it'd be just one line like this, right? So X can actually change where it can be. By differentiating our cost here with respect to X, what we're actually doing is finding at what point is this X along here such that our cost is the cheapest, right? So for example, if X was all the way out here at 5, then the cheapest cost would be going P to S. If our cost here was in the middle, let's say 2.5 in the middle right here, our cheapest cost would be going from P to S, right? So that's the, I guess, backstory and understanding of what X really means in this equation. So by knowing that, we know that by differentiating this equation here with respect to X, we can find the minimum cost at what X value it occurs at. So let's do just that. To differentiate, see with respect to X, 1,000, differentiate 5, which is gone, differentiate minus X is 1, differentiate 2.6 times X squared plus 9, so 2.6 multiplied by, so I'll show you a quick trick here actually. Whenever you're differentiating a square root, what it really is actually, so this is U is what's inside the square root, you differentiate what's the u is divided by 2 root u. So let's actually apply this formula right here. So you differentiate what's inside the square root, x squared plus 9. Derivative of that is just 2x. 2 root u, 2 root x squared plus 9. Cool. So that's actually a quick way you can differentiate these square root equations. So to find the minimum once it occurs, we need to know where our stationary point is. So that's when our DC on x equals 0. So let's find that. X equals 0. So DC on dx equals 0. So 1000. Let's rewrite this exactly. Minus 1 plus 2.6 x here. So let's cancel these 2's and 2's out. So we left x on top. All divided by x squared plus 9. All equals 0. Cool, so let's continue solving for this equation. So 1000 on the outside, we've got a 0 on the outside, we can just get rid of it. Minus, so we've got this here, all equals 0. So let's solve for that. Minus 1 plus 2.6x root x squared plus 9 equals 0. So we're going to keep solving for x here. So let's throw the 1 over to the other side and multiply this x squared plus 9 upwards as well. So 2.6x equals, so remember throw the 1 over, so this is 1 now. If we multiply by x squared plus 9, it would just be x squared plus 9. Cool. So continue. So we want to get rid of this square root because we can't work with them. So we want to square both sides. So let's square both sides. 2.6 squared x equals x squared plus 9. So this is now where we can really start see how our answer comes to life, right? So continue calling for x. So it's actually x squared. So we should throw the x squared to the other side. X squared 2.6 squared minus 1 equals 9. X squared equals 9. 2.6 squared minus 1. So let's find this x straight away. Let's put this number here into our calculator and let's square root it. So 9 divided by 2.6 squared minus 1 and square root the answer, 5 on 4. So let's write things in decimal place because it's actually a distance. So we know the minimum cost occurs at x equals 1.25. So what does that actually mean, right? That means in order to get the lowest cost of laying that cable, this distance here actually has to be 1.25. So it'd be probably around over here. So the cable would go like this, over here, then it's up like this. That's where we get the minimum distance, right? With these current costs. So before we actually start using this equation, we've got to, I guess, verify that this is actually a minimum, right? So we're not actually 100% sure right now that this 1.25 is actually a minimum, will give us the minimum cost, but we've got to, I guess, make sure that what x.125 isn't actually resulting in the maximum. So quick way to do this. So we have, you might have seen it before, maybe you've seen it. So this is just a quick way to see if things are a minimum or maximum. So we know that 1.25 is our stationary point. Y dash is our gradient, our derivative. So we know y dash equals 0, x equals 1.25. So we want to understand the behavior before and after the stationary point. So let's sub in an arbitrary value, 1.2, 1.3. So number bigger and number smaller than 1.25. And let's put those numbers actually into our derivative function. This should be dc on dx actually, if I want to be accurate here. So 1.2, 1000 minus 1 plus 2.6 root 1.2 squared plus 9 times 1.2. What's this equal to? Hopefully it'll be a negative number. Yes, it's a negative, minus 34, but we just write a negative number. And if we do the same thing for 1.3, we get a positive number, 33. So what does this mean? This means the curve coming up to 1.25 is decreasing, so positive and negative. It flattens out and it's increasing again afterwards. So this represents a minimum, right? So that means we're safe to use this 1.25 as the distance which results in the minimum cost. So let's find the actual minimum cost. So let's get our cost equation from initially there, and let's sub in x equals 1.25. So that I'm not going to actually write it all down. We'll just put the 1.25 straight into the equation that was in part I. So 5 minus 1.25 plus 2.6 root 1.25 squared plus 9, close the bracket, is 12,200. So that's our minimum cost. So what does this all mean? Let's re-explain. So we know our minimum cost now is 12,200, right? We've just found that. So 12,200. We know the distance at which this occurs is 1.25. So what that means is if we wanted to lay a cable from P to S, right, while minimizing the cost, that would be when this distance here, X, is 1.25, so roughly over here. So this line probably go down to over here. And that cost associated with that would be 12,200. So the table would go here, like that. That's where we get the minimum cost. So that's how we interpret the question, I guess, in words. Cool. So that's part IV done. Part 4, I guess that's the hard part. Let's move on to part 5. Part 5, worth 2 marks. New technology means that the cost of laying the cable underwater can be reduced to 1,100 per kilometer. Determine the path for laying the cable in order to minimize the cost in this case. So if we remember what we did in the previous part, if we remember what X did, what X told us was that, it told us the distance, this distance here, right? Given, and this distance could be anything, right? Remember, X could have been 5, X could have been 4, 3, 2, 1, 0. But it helped us, what solving the previous question helped us do was it helped us understand what value of X gave us the cheapest cost. And the value of X actually tells us the path of the actual cable. So remember what I said before, if the result was that X equals 5 from differentiating, that means this line will be all the way out to here, right? It will be all the way out to here, and our lowest cost would be going from P straight to S. If X was in the middle, let's say 3, the cheapest cost would actually be going from P to 3 here, and then up to S. If X was 0, be going P to R to S. So X here actually represents a variable which the cable can be. So let's actually rewrite our cost equation from our cost equation now that our cost of laying the cable underwater has now been decreased for part V. So part V, our cost of laying the cable underwater is now 1,100 per kilometer. So total cost now, it would be C PQ plus C QS, right? So cost PQ, same as before. So this is still on the shore, right? So our cost actually hasn't changed. It's still 1,000 multiplied by 5 minus X. Cost of QS here. So now this is the one that's changed. It's changed down to 1,100 per kilometer. So this is now lower, multiplied by distance QS. So you saw QS in the previous part. We did Pythagoras theorem to find the QS distance. It's root x squared plus 9. Right. So the cost of which we're actually finding here is this here, PQS, right? And if X, when we differentiate, if that ends up being 5, then we know that the lowest cost occurs when we go P to S, or when X equals whatever number, that will tell us when the minimum cost occurs, right? So let's differentiate this equation to find what X value occurs. So let's actually clean this up such that it's something easy to work with. Let's factor out the 1,000 like previously. 5 minus X. 1,000 divide that out of 1,100, it's 1.1 x squared plus 9. Cool, so that's our cost equation with our new $1,100 cost. Cool. So let's keep going forward. Let's differentiate our this with respect to x so we can understand what path is required such that we have the lowest cost. So differentiate this. We've done this all before, so very similar, pretty much exactly the same as before. Differential 5 is gone, except the only difference is we've got 1.1 instead of 2.6, like unlike last time. 1.1, same as before, and we know this is going to be like this. So we want to find the minimum. That's when dc on dx equals 0. 1,000 minus 1. 1.1 x squared plus 9 equals 0. Cool. So get rid of the 1,000. 1.1 minus 1. 1.1 x squared plus 9 equals 0. So very similar to the previous part. See here, well, the working out is pretty much exactly the same as we did in the previous part here. Only difference is we've got a 1.1 this time instead of a 2.6 because of the new cost of laying the cable underwater. So let's do this quickly. 1.1x equals x squared plus 9. So just throw the 1 over, multiply the x squared plus 9 up. So get rid of the square, we've got to square both sides. Equals, oops, sorry, x squared plus 9. Cool. What we're going to do now, continue solving for x. So x squared, 30 is x squared over, so it's 1.1 squared minus 1 equals 9. X squared equals, oops, 9 on 1.1 squared minus 1. X equals, let's put in our calculator. Square root that, 6.5. But wait a minute. Let's take a step back for a second. 6.5. That's 6.5 is the distance required such that our costs are minimized. 6.5. So actually, when we look at x here on the diagram, x can't be 6.5. Do you know why? Because this distance here is 5 kilometers already. If x was 6.5, this distance would be all the way out here, and that's not possible. So because x is 6.5, and because of the fact that x has to be less than 5 kilometers, the shortest distance we can actually take is this is when x equals 5 kilometers. So x has to equal 5. So essentially, that's right. Because x has to be less than 5, right? 5. Minimum cost occurs at x equals 5, not x.65, because at 6.5, it's not possible. It's not possible for x to be 6.5 because this line here would be all the way out here, and that's just not possible. It can only be out to here, 5 kilometers. So, knowing that our minimum cost occurs at x equals 5, what does it actually mean? So when x equals 5, this line out here doesn't go out to here anymore. It goes all the way out to here. See, this line here doesn't go to here because x equals 5. It goes all the way out to here. And what does that mean? That means our minimum cost actually is laying the cable from P to S without any bends. Because for example, if x was 4 here, our cost of laying the cable would be going to here and then upwards. But because x is equal 5, to minimize the cost, it'd just be going from P straight to S. So, because of that, therefore, cheapest cost is laying from P straight to S. Cool. So that's question finished now. So what do we learn from this question? I guess if this question, if you couldn't figure out in the exam straight away, I think what's important is that you're able to pick up marks in the first 3 parts, especially because the first 3 parts, it's just applying basic multiplication, right? Find the cost per distance, multiplying that by the distance will give you the total cost. And that's for the first three parts. I guess the tough part there is knowing that you've got to use, I guess, Pythagoras to find unknown distances. But if we can see that there's a right angle triangle, if we see there's right angle triangles inside this question, I think that we should be safe there. But the tough part here is understanding what the x actually means, right? X is a variable. X can be anything between 0 to 5. So when we're finding the cost relative to x, what we're really doing is finding any potential cost of laying the cable, right? Because if we wrote x equals 0, that would be the cost of laying the cable from P to R to S. If x was 5, it'd be the cost of laying the cable straight from P to S, because the line would be out here, right? And that's especially important when we solve the last part of the equation, where we know we can use this equation here to actually help us find the cheapest path of laying the cable. Cool. So good request, Scott, for this question. Please, everyone, keep your requests coming. 2-unit, 3-unit, whatever you like. We're happy to solve any questions, and inbox our Facebook page, and make sure you follow the YouTube channel as well. That's where a lot of our stuff is archived onto. And as always, if you have any questions yourself, please send them through. Cool. Thank you for watching. Bye bye.